All right, there we go. Everybody ready? Ready, set, go. It's the end of chapter 10. Let's see. I think I'm recording. Am I? Maybe. All right. So last time we learned about an empirical formula, and empirical formulas are what? What are empirical formulas? Yeah, Mally, I'm trying to make it so that they're not looking at my middle part, but okay, it's okay. It doesn't matter. It's good. It's good. Yeah, it's the simplest. It can be reduced, right? If you end up with the ionic formula, it should already be reduced because that is the definition of an ionic formula. It's when the simplest whole number charge ratio, right? Molecular formulas are what we actually have. So C6H12O6, when you look at it and you can see that it can be reduced, then you know that is a molecular formula. That is the formula for glucose, right? So the question is, how do we get from an empirical formula to that? Well, if you scale it down, you must be able to scale up from the empirical formula. What is the empirical formula for that? Yeah, CH2O, right? Because we can reduce it by a factor of 6. So the question is, where does the 6 come from? And we can calculate that. We can, see what I mean? They're like looking at my used to be my best part, but you know.
Are you on Zoom?
Yeah, I'm recording it in Zoom.
Oh, that's smart. Wow.
All right, there we go. For the people that are absent. All right. So it is a ratio. It is a ratio. If we can scale up or down, we just need to know what that factor is. Sorry, Melly, I don't know what to do.
Oh.
So let's look, we've got two examples, all right? We've got benzene, all right, and we've got acetylene, and they have the same empirical formula, which is CH. But we know that we know that chemically and structurally, they are very different. So we just need to figure out what their molecular formulas are. You need 2 pieces of information to find a molecular formula. You need the empirical formula and you need some experimental data, right? Experimental data means we got that from the lab. For example, we need this really should say some kind of experimental molar mass of acetylene is 26.04. And the empirical formula mass is the second piece that we need. We need this and we need this. We need the empirical formula. We are given both of these. Our experimental mass is 26.04. What this formula mass means, that's 12.01 for carbon and 1.01 for hydrogen. That's where we get 13.02, right? We got that from that. So that's our ratio. The empirical formula and the molecular formula are another ratio. If we take the acetylene over our, I'm sorry, we're looking at acetylene. There's what we found in the lab. This is like some kind of lab data. And you have to be given that, or you go in the lab and find it yourself, but generally given. You take this empirical formula mass that we added up, that's at the bottom. And that ratio is always going to be a whole number. John Dalton said things combine in whole numbers, and we've already gotten a whole number from our empirical formula. So I don't know how to move that out of the way. So we see that our ratio, there's no good place for that thing, is it? We find that our ratio is 2. So if we take CH, our empirical formula, and scale up by 2, we have our formula, our molecular formula. Oh, it didn't. Oh, sorry. So we would take this, multiply it by 2, and the answer is C2H2. That is our molecular formula for acetylene. We can do the same thing for benzene, and that's on the next slide, right? It was given to us. No, it would have to be given to us. Our lab data, right? We already found that. That's our second piece. that ratio tells us that we need to scale up by 6. So CH times 6 is C6H6. I hope, does that make sense that we went, if we had this and we scaled down by a factor of 6, that we would scale up by a factor of 6? The question is, where does the 6 come from? So the 6 is something that we have to calculate. And that would be this piece of information that would have to be given to you. This piece of information, you could calculate it if you were given the mass percent of those, the elements involved. You could find, we know how to calculate that from mass percent. That ratio, right, tells you your N, we call it an N factor, or you could use X. It's just a factor. Does that make sense? That's how you know, this ratio between the empirical and the molecular formulas. Cool? All right, let's work a problem. If I can get to the thing. So it's a ratio. You have to either be given this experimental mass, or you would, in practical terms, we'd be in the lab and we would find it. And that's kind of what we'll do when we do our lab next week. Sometimes you may have to find the empirical formula first. And that's when you see a problem and there are percents in there, you just go, because that means you're going to have to find your empirical formula and then do this step to find that factor to scale you up, right? And then you multiply and you've got your formula. Cool. All right, let's look at example 1. Oh my goodness, I know, I just can't find a good place for that. There we go. So experimentation shows the formula mass of diborane to be 27.67. So when you see this word, that's how you know 27.67 is going to be on top, right? Because this is what I'm looking for, the X or the N, whatever variable that is. That's the number that you're going to scale up, right? The formula mass of the empirical formula, so there's my empirical formula, 1 boron plus 3 hydrogens is this much. So that's this number. This whole ratio is 2. That means I take my empirical formula, I'm going to scale up by a factor of 2, and my actual molecular formula is B2H6. Does that make sense? So all you need are 2 pieces of information. How you're going to remember it, I would make a flashcard, or I would make up some story. Somehow you're going to have to remember it. New stuff is hard to remember. New stuff can be hard to learn too. All right, let's get the next slide. Whoops. All right, here's our example number 2. And let's see what we've got. Empirical formula of phosphorus and oxygen, yay. It was given to you, so you smile. You smile about that. Experimentation, there's your key. What is the compound's molecular formula? So you know it's some kind of experimental data over the empirical formula mass equals some factor that we're going to take the empirical formula and multiply it by to find our molecular formula. So that's easy. We've got 283.89 over, we just need to find P2O5. I feel like this might be on the next slide. It is, yay. So two phosphorus, there we go, 30.97 plus 5 times oxygen. Right, we're gonna get 141.94. So here's our formula. There's our lab data. Some kind of experimental data. This came from the empirical formula mass, right? This number right here. When you divide it, there's our ratio, and you're solid, that's a solid 2. That's a good whole number, and we won't have any weird surprises with that, where you have to multiply or do anything. That's fine in your empirical formula. You have to do that sometimes. So 2 times P2O5, we get P4O10. Just checking. Just checking. Dalton, is there a reason you're on your phone? No, is there a reason you're on your phone and or sleeping? Please don't.
No, well, I know you're not sleeping.
All right, here's your spreadsheet, or what do you call it? Flow chart. So if you've been given percent composition or mass of components, you know that's when you go, there's your percent to mass, then you've got mass to moles, right? We can divide by small, and we can either multiply or round till whole. Then we've got our empirical formula. From the empirical formula, you've got some kind of experimental data that's given to you. You divide it by the mass of the empirical formula itself. You're going to multiply the empirical formula by that factor, and there you are. You arrive at your answer. So we'll work a couple of examples together. And there was a mistake when I made the copy for you. Make sure you X the back of it. And I don't even think this is the one you got. I think you just have 3 questions, don't you? Yeah, the back goes to something else. So don't do the back. Just X it out. Yeah, it should, it says like aspirin or something. That went with the empirical formula. So just never mind. And then you don't have the answers either. It's kind of a pain. So we'll work the first one together. And this is when you look at it and you cringe because you're like, I'll be darned. What have you been given? Percents. You see percents, you know you're gonna have to work out the empirical formula. From the empirical formula, you can work out the bottom part of that ratio. Do we have some kind of, 118.1, there we go. So we can find the empirical and molecular formulas for succinic acid. So we're gonna set up 40.68 grams of carbon, 5.0 grams of hydrogen, and 54.24 grams of oxygen. Do a little molar mass, 1.01 grams of hydrogen, 1 mole of carbon is 12.01 grams of carbon, and 16 grams of oxygen is 1 mole of oxygen. Cancel, equals. So 40.68 divided by 12.01. 3.387177. 5.08 divided by 0.01. And I got 5.02970. Why am I using such big numbers? Well, I'm writing down all the sig figs that I can, right, to get a better answer. And did I already tell y'all that CK12? There was a bad question in there. It was the one, it only gave you two sig figs. It was like 72% hydrogen and 20-something%. That, I asked my husband, I was like, what's going on with this question? I was like, I can't figure it out. And he was like, that's because it's a bad question. Two sig figs is not enough to work it out. And then I went back in and I think CK12 took that question out because I can download it and it wasn't in that mix. So I feel like that was a bad question. Don't expect anything. It was just a bad question. Look what's happening here. Yeah, these are the same one. That's the same thing as 3.39. So there's that one. We know this one is 1. We just have to divide that one by 3.39. How many? What do we get? 5.029703 divided by second answer. Yep. I figured it would be as much. Your textbook really likes this. So what are we gonna have to do? You got half an atom, which won't do. We gotta fix the whole mole ratio. Yeah, multiply the whole thing by 2. So that gives us an empirical formula of C2H3O2. There's our empirical formula. So we may as well find the mass of it. What is that? 24.02 and 3.03 and 16 and 16 is 32. So 24.02 plus 3.03 plus 32. I got 59.05 grams. So let's just take it back over here. We were given 118.1 grams per mole over 59.05 grams per mole. So 118.1 divided by second answer. Heck yeah. That's, you did it right if you get a whole number at that point, because they are not going to mess with that. That's my factor. So we scale up by 2. So we're going to take this 2 and multiply C2H3O2. And that's going to be our answer. So it is C4H6O4. That's the answer. Okay. I'm going to turn off my record.